Good morning, class. I'm going to help you get a little bit further on those notes today so that you can get back to work on your graphing worksheet and start the new worksheet on the application problems. You need a calculator today. You need these notes out, and you need the new notes out that say modeling growth and decay. Press pause if you need to. So I'm just going over what we did yesterday was learning the exponential growth and decay graphs, remembering our exponent rules along the way. We talked about the most basic types of exponential equations. And then we started talking about an application problem about zombies taking over. So we're right here. And today, when we're going to be writing exponential functions, you want to be able to identify your initial value and then your rate or your multiplier. Most of the time, you're going to then raise it to an exponent that is based on time. The most basic exponential function is just y equals anything to the x, but today we want to use growth or decay specifically where we take 1 plus a rate or 1 minus the rate. And your percent can be turned into a decimal or a fraction, but you need one or the other in order to type it into your calculator. We then actually transition to using balance or amount in this case. Ending amount or ending balance is another way to think of it. That you have to start with a principal amount P, and then 1 plus or 1 minus the rate, and then to the time, usually years, but some will be in months or days or any other time increment. An example of the ones we're going to be writing looks like this g of x function. This is a decay rate because our multiplier is between 0 and 1. When you're maintaining 61%, you're actually losing 39%. And then also notice 452 sits in front of the multiplier. It is called the initial value or starting amount. And then this next one, because the multiplier is bigger than 1, it is a growth. The starting value of 30 is in front, and it's a percent increase of 42%. You just have to take away the 1 to calculate that. Press pause on the video if you need to. And then get out the second page of notes. Here we're going to start using those two equations, and I've already done these two examples where if you need the step one where you identify your principal, your rate, and your time, you can give yourself sort of a little cheat sheet list of the things that you know so that then you can plug them in and substitute them into the formula. For example, here, then since the ending amount is the one that you don't know, you're just going to type that in your calculator exactly as is and get some amount of some ending amount. And in this case, when it's people, you just want to round up or down appropriately. And the one next to it, these are both about cities either growing or decreasing in their populations. So the one next to it is a city decreasing by 6%. Identify your principal amount, your rate, and your time, plug them into your formula. And then notice if you prefer sort of how this one looks when you just already take 1 minus 0.06. That also is faster to type in if you like it. And then again, round to the nearest whole people. We'll do these next 4 examples, and then you'll get started on your own. Sales at a company are 372,000 and increasing at a rate of 5% per year. How much will their sales be in 8 years? So again, set up the equation first. I would love to see this written on your paper when you're doing these problems on a quiz or a test. Principal amount times 1 plus the rate since it's growing. Remember to change 5% to 0.05, raise it to the 8, type it in your calculator. And in this case, we would want to round to the nearest hundredths place because it's money. So the ending amount is $549,613.43. The next problem is about a population of a town. It's growing. It says increasing at a rate of 3%. What's the initial amount of people now means we don't know P. You still want to set up the equation, but now we have to do inverse operations to isolate that P. It is attached to this with multiplication, so technically I would need to divide all of this out, but I can turn it to one single number before I divide both sides by it. So I did that over here. If you see me using a lot of decimals, it's just because the more you use, the more accurate your answer will be. And so I would encourage you to even when you type something like that in the calculator and you then need to divide by it, go up and grab it and highlight it on that previous row in the new operation of your calculator. Here, these would cancel out because we're dividing by them, and your answer is about 4,202 people. Check the reasonableness of that. It should be smaller than the ending amount since it was principal and it was growing. Okay, next, a monthly car sales is decreasing from 350,000 to 291,000. That means we know A is the smaller amount and P, principal, is a larger amount since we have a decay going on right here. We know it was for 6 months, so our exponent this time is going to be 6. Again, since this is being multiplied by 1 minus r, and this is the variable we're going to be solving for, I want to get rid of this number first, so I have to divide it out. And then you get this decimal 0.833. We take these off for a sec. And so you still can't subtract 1. You can't add r. You can't really get rid of that 6 unless you take the 6th root. And this is a function that your calculator can always do for you, but make sure you do it to both sides of your equation. And when I typed that in, I got exactly this number down here. Math number 5 on your calculator is where you access any root that you need, and you just need to type in the 6 on the index number. So then you can have your 6 power and your 6th root cancel out. You're left with 1 minus r on the right. We do need to subtract 1 so that these cancel. And even though you get a negative rate over here, r is still negative here. You can divide out that negative or just know that that is the same thing as r being positive 0.03 or a 3% decay. And the last question, back to a simpler one. An internet chat room starts with 1,200 people. It's decreasing at a rate of 2% per year for 5 years. So plug in your principal amount of 1,200, do 1 minus your rate as a decimal, raise it to the 5th. Just type that in exactly in your calculator, round it appropriately. This is people, so whole numbers make sense here. 1,085 participants. These notes are already uploaded. If that went too fast, you can always click on the link and play the video quietly yourself. Actually, not the video, but you can open the notes. And then I just want to remind you on our plan of attack, this worksheet 6.1 is the worksheet that we started yesterday that had the graphs on it. Now you're going to also want to start worksheet 6.1b. You're only attempting 1 through 7 on it. There is an answer key on the back. Use your calculator, but set those equations up first. And I hope this video helps you make sense of these problems and you make a good attempt. Thanks, bye.